Today we're going to start chapter 12, which is on solutions. And today I'm going to talk to you about what a solution is and some definitions related to solutions and some examples. And then we're also going to cover what an electrolyte is and how that relates to a solution. So first, let's talk about what is a solution. So a solution is a homogeneous mixture, which remember means that it's mixed evenly throughout. A homogeneous mixture in which the solute is made up of small particles, which can be ions or molecules. And in a solution, the solute is the substance that we have less of. That's the thing that's being dissolved. And the solvent is the substance in which we're dissolving the solute, which is frequently water, but not always. And it's always the thing that there is more of in your mixture. Now let's talk about a few examples of different types of solutions. So liquid solutions are probably the ones you think of first, and most people think of solid and liquid solutions first. So an example of this would be seawater, for example, which is water with sodium chloride, which is salt dissolved in it. So in this case, water would be the solvent, and NaCl, sodium chloride, would be the solute. Liquid in liquid solutions are also possible. Vinegar is one example of this. So again, water is the solvent in this case, and then the solute in this case is acetic acid, which is what gives vinegar that characteristic smell and taste. Okay, gas and liquid solutions are also possible. Again, here, often water is the liquid, but it doesn't have to be. But an example of this would be sodas. So sodas, for example, the solvent is water, and the solute is carbon dioxide, which is a gas, and that's what gives them their carbonation. That's where that comes from. Okay, now let's talk about gas and gas solutions. So air would be the most common example of this, and the largest component of air is nitrogen. So that would be the solvent in that mixture, and the solutes would be things like oxygen would be the most prevalent one, but then hydrogen, there's some helium, there's other gases that are also part of our air. And then last but not least, solid solutions, which I think we probably think of the least. These most frequently are metals that are mixed homogeneously with other metals. So for example, brass is zinc dissolved in copper. So copper would be the solvent in that case, and zinc would be the solute for brass. Steel is another example of this. And in steel, we have iron as the primary component, so our solvent, and there's actually carbon dissolved in that iron to make steel. So that would be the solute in that case. Okay, so in all of these cases, in order to get things to dissolve, they have to be similar in their chemical properties. And we call this this property like dissolves like frequently. And what that means is that they just, in order for two things to dissolve, they have to have similar polarities. So polar things will dissolve in polar solvents, and nonpolar solutes will dissolve in nonpolar solvents. But the opposite is not true. So things that are polar will not dissolve in a nonpolar solvent, and things that are nonpolar will not dissolve in a polar solvent. Right now, I said we were going to talk about electrolytes in this video as well. So what is an electrolyte? An electrolyte is something that when it dissolves, it also dissociates. And so that leads to the question, what is dissociation? Dissociation is when separate ions or ions that are present in the compound separate in the solution, and as a result of that, cause the solution to conduct electricity. And that's why these things are called electrolytes, because they give the solution the ability to conduct electricity. Non-electrolytes will dissolve in water, but they don't separate into their specific ions. So we looked a little bit on Friday at the salt and sugar simulation, and salt, you should have noticed, separates the two ions, the sodium ion and the chloride ion separate from each other, and that would make salt an electrolyte, but sugar did not, so sugar is a non-electrolyte. Okay, we can also divide electrolytes into two different categories. Strong electrolytes are ones that dissociate completely when they are put into water. So sodium chloride is one example of that we looked at in that simulation. All of the sodium ions separate from the chloride ions. None of them stay together. A weak electrolyte is one that will dissolve and dissociate partly, but some of it will remain undissociated. And so we're going to talk about a couple examples of those. But first, I want to just mention that we write these reactions a little bit differently. So for a strong electrolyte, we're going to continue to use the single arrow that we've been using. So we'll write that if we had sodium chloride, we'd say sodium NaCl put into water with a single arrow gives us Na plus Cl minus. Okay, and then because we started with a solid and we're going into solution, our phase changes to aqueous on the product side. For a weak electrolyte, we're going to write these a little bit differently. So HF is one example of a weak electrolyte. And so HF, when put into water, will partly dissociate. And so we write that with a double-headed arrow because some of the HFs will become H plus and F minus, and some of them will go back to be just HF in solution. So when we write the double arrow, it's going back and forth between undissociated over here and dissociated over here. But in both cases, they're dissolved. So in both cases, we have aqueous on either side. Okay, so let's just go over a summary of that you can put in a table to help you remember. So a strong electrolyte, it dissociates completely. The types of particles in solution are only ions. So ionic compounds are the only kind that can dissociate. And strong electrolytes, since they dissociate completely, ions are all we've got. And they do conduct electricity. And some examples of this are NaCl, KBr, MgCl2, a lot of the ionic compounds that we've talked about. And then there's also some acids that do this as well. Hydrochloric acid, HCl, and HBr are other examples of that. So in terms of what this looks like on a particle level, we have positive ions and negative ions, positive ions and negative ions. All right, and all of that is dispersed throughout the water molecules. So a weak electrolyte dissociates partially, and the types of particles that we'll have there are mostly molecules and then a few ions. So some of them separate, but not all of them, all right? And they will conduct electricity weakly. So it just depends on the particular molecule that you've put in, how much it conducts. Like I said, HF is an example of this. Water is an example of a weak electrolyte. Ammonia, acetic acid, which is what's in vinegar, those are all weak electrolytes. And in this case, what you would get is some of them will separate into the positive and the negative ion, but then you also have some that stay together as one unit dissolved in your solvent, whatever it is. Okay? And then a non-electrolyte does not dissociate at all. You only have molecules present because nothing separates. Non-electrolytes do not conduct electricity when they dissolve in water. And some examples of these would be things like sugar, which I mentioned and we did in the simulation. Ethanol is another example. A lot of organic compounds are non-electrolytes, things that have carbon in them. Okay, and so in terms of a particle diagram for this, you're just going to have molecules. All right, they're going to separate from each other and the water will be between them because they're dissolved, but they aren't going to separate into separate species from there. Okay, so that wraps up our discussion of solutions and what electrolytes are, and we're going to do lots more with this in the coming days in class.